To update the database information using code, there are two possibilities. Do it using the transaction's business component through its insert, update, or delete methods, save and insert or update, or do it exclusively within a procedure through the new, for each, and delete commands. In other videos, we study the first case in detail. Now we'll focus on the second one. It's very important to keep in mind that this second type of update can only be performed in the source of a procedure. The commands we'll study will not be valid anywhere else, such as panels or web panels events, but only here, in procedures. Let's start with the command that allows inserting a record into a table. It's literally one record and in one table. Suppose that we have the attraction transaction, which records tourist attractions, where there will also be a country transaction that records the information of each country and its cities, and a category, which records the categories in which the tourist attractions are classified, and that we want to insert Christ the Redeemer through a procedure in the table associated with attraction. To this end, we have the new command executed in the source of the procedure, assigning a value to each of the attributes of the table for the record we want to insert. Here we'll be working directly with the table, completely detached from the transaction that creates it. That is, the rules of the transaction don't matter, and neither do the events, nor anything else. The new command is completely indifferent to the transaction. The only thing it pays attention to is the composition of the database table into which it'll try to insert a record. So here, the inferred attributes or transaction formulas are not involved at all. They don't exist for the new command. The only ones that matter are the table attributes. For this reason, in this case, we've assigned a value to all of them. Is this mandatory? Of course not. If we don't assign a value to an attribute, it'll be considered empty. Thus, if we don't assign a value for attraction name, attraction 5 will be inserted without a name, even if there is an error rule in the transaction that prevents it. As we've said, the transaction here only serves to give existence to the table in the database. This is a first major difference with the insertion through a business component. But what if the primary key is not assigned? An attempt will be made to insert an empty key record, as if we had explicitly assigned 0. If the primary key is not auto-numbered, then if a record with that ID 0 does not already exist in the table, it inserts it. But what if it already exists? It won't do anything. We won't see any difference between having executed the new command and not having done so. That is, the new command controls the uniqueness of records. It won't insert a duplicate key record. The same will happen if the attraction with ID 5 already exists in the table when we're going to execute the new command. Here, it won't do anything at all, due to the uniqueness control. And this is true for both primary and candidate keys. Let's imagine, for example, that attraction name is a candidate key. In other words, we have a unique index defined over this attribute. And let's suppose that the record of ID 3 had as attraction name value the same one we're now trying to insert as record 5. When the new command is executed, it will do nothing. This is because it'll find that there already exists a record with the same attraction name as the record we want to insert. Now, going back to what we were wondering about what happens when we don't specify a value for the primary key, if it's auto-numbered, then it'll never fail due to a duplicate primary key. It'll always insert a record with the next number. How do we know what number was assigned to it? The value in the attribute is stored in memory immediately after the new. Thus, we can, for example, assign it to a variable so as not to lose it the next time the attribute is used. What about attributes that are foreign keys, such as country ID, city ID, category ID? Does the new command perform referential integrity checks? The answer is no. This is because the command update was created to have a fast update method with the best possible performance. Performing these checks always slows down the operation. When dealing with a single record, this doesn't matter. But let's think about what happens if we have to insert millions of records. So, for example, if for the new record we want to assign a country with ID 15, the new command will not check that there's a country with that value in the table that stores the countries. It'll insert the record without any problem, and the database will be left in an inconsistent state. Let's go to GeneXus to try it. We have the 3 transactions with data. In particular, attraction has these 4 records. Attraction ID is auto-numbered. We've created this web panel where the user will press the New Attraction button, which will call a procedure that'll try to insert a new record in the attraction table for Christ the Redeemer. The procedure will return the attraction ID that the database assigned into the inserted record. With this, we create the message that the user will see in the panel. Let's try it. Attraction 5 was inserted. Let's see. And here is, indeed, attraction 5 inserted in the table. Now let's see what happens if we want to assign a non-existent country for the new record, such as this one. We run it, and the program crashed, when in fact, we expected it to have inserted the record without any problem, since we said that the new command doesn't check referential integrity. So what happened then? It's true that the program is not checking referential integrity, but the database is. So the new command tried to perform the insertion, but the database wouldn't let it, and threw the exception. By default, the database checks referential integrity. We can turn off this control by means of a property. But what we clearly see is that the new command is not doing so. That's why we have to be very careful when using this command, because this type of program crash is unacceptable to the end user. What if we leave a foreign key unassigned? Again, the new command will not perform any check and will try to insert the record. If the database makes them, then it'll throw an exception like the previous one that will stop the program if it's not caught and handled by it. We might think that if the attribute accepts nulls, it'll never fail because the database will allow that null for the foreign key. However, we must be careful about how the database interprets that it's a null and not an empty value. We'll discuss this in another video. If everything is okay, then the new command inserts a record in the table. And what happens with the commit? If we look at the navigation of the procedure that we executed a while ago, it's showing a warning that says the program could be called by another program, and that the commit on exit property is set to yes. We can see it here. This property is also found in the other object that operates on the database, the transaction object. Here we see it below the transaction integrity group. In another class, we'll study this important topic, which is how to define and achieve transactional integrity. The important thing is that if this property is set to yes, it means that an automatic commit will be added in the object's source code. That is, as long as the object performs some operation on the database. In the transaction, at the end of the operation on the header and its lines. In a procedure object, at the end of the source. That's why we didn't have to specify it. If the property were turned off, then we would have to explicitly write the commit command, just as we did with business components. To sum up what we've seen so far, when trying to insert a record into a table using the new command in a procedure, the command performs uniqueness controls by primary key and candidate keys, thus ensuring that a record is not added to the table that duplicates the key. If it finds a duplicate key, then it does nothing. If any attribute of the record to be inserted is a foreign key, the new command will not perform a referential integrity check. That is to say, it will not search the table that's referenced for the existence of a record with the value that we want to use in order to insert the record. But if the database has referential integrity declared, then it'll perform the check and cancel the program if integrity is being violated. If it doesn't have referential integrity declared, then the insertion of the record will be allowed, regardless of whether it violates integrity. And regarding the rules and events found in the transaction associated with the table, these clearly have nothing to do here. Let's remember that for the new command, only the table matters, not where it comes from. However, we might want to perform some action if the record is duplicated by a key. For example, instead of inserting it, update it. In the example, we may want to change the value of category ID. To this end, the when duplicate clause is used. The code it contains will only be executed when the primary key or candidate key is found to be duplicated. If what we want in that case is to update the record, then we have to do it inside a for each, as we see here. Values are not assigned directly to the attributes to be modified, as you might think. Instead, this has to be done by writing a for each without having to filter by attraction ID, because it's already implied. This is the way the new command understands that we want to update those attributes of the record it found duplicated. In this case, update only the category ID attribute. Here it would be possible to update attributes of the extended table. Returning to the issue of what happens to the attributes of the new command table that are not assigned a value, we had said that they remain empty, but it actually depends on the context. They're empty if they're not instantiated in the context in which the new command is found. In other words, if they have no value. For example, suppose we're running through the cities of France with a for each command and print each one, for example. In addition, we immediately execute the new command that we're looking at. So first of all, how does GeneXus determine the base table of the new command? By paying attention only to the attributes to which a value is being assigned. It has to find a table in the database that contains them. It'll clearly be attraction. Does this city name take part? No, it doesn't. If it's there, it's because in the context in which we've written the new command, we know that it is instantiated. This city name will be that of the for each. In sum, for each city, we want to insert a new tourist attraction with the name of the city and category 2. Okay, but what attraction, country, and city identifier will be assigned to the record to be inserted? In this case, the only empty one will be attraction ID, which is not instantiated in the context because it isn't in the extended table of the for each. And it's not received by parameter in the attribute either, which is the other instantiation method we know. So if attraction ID is auto-numbered, then when the record is inserted, the database will give the next one to the last number. However, country ID and city ID are instantiated in the context. Therefore, they'll be assigned this context value. In this case, the country and city in which we're positioned in the for each. And then the same will happen for the next city in the for each. What would happen if we wanted the same two records to be inserted in attraction, but with an empty attraction name? It would seem that by simply not assigning a value to attraction name, we would be implementing it. However, if we look at the attributes that GeneXus will use to determine its base table, that of the new, there is only category ID. Therefore, it will not choose attraction as the base table, but category. So, how do we have it choose the attraction table? One possibility is to explicitly assign the empty value for attraction name. Because in this way, by naming this attribute, it'll participate in determining the base table, and it will make the base table to be attraction instead of category. The other option is to use the defined by clause that allows adding more attributes to be considered together with the others in determining the base table. In short, the new command is used to insert a record into a table. The table is determined by the attributes assigned to it. If a defined by clause is added, then the attributes listed there also participate. Here the concept of an extended table does not make any sense. On the other hand, we had seen that the only programmatic control performed by the new command is the uniqueness control, and that if a record was found with the key we're trying to insert, then the new command did nothing unless we had programmed the when duplicate clause. And we had said that there, among other commands, we can include a for each to update attributes of the record that was found to be duplicated. Can all attributes be updated? For example, can the primary key be updated there? The answer is no. But it will be possible to update attributes of the extended table. Finally, for the record to be committed in the database, we must make sure that the commit command is executed. In a procedure, by default, an implicit commit is placed at the end, but we can explicitly write commits in the source where it's convenient for us. We won't see it here, but optionally, a blocking clause can be specified, which allows making insertions in the database in blocks, instead of record by record, as long as the new command is inside a repetitive structure. This will clearly be used for efficiency reasons when batch insertions are very large. Next, we'll see how to update through a procedure.